Next one is what? Properties of colloids. Properties of colloids. The first property, namely kinetic property of colloids, nothing but Brownian movement. What? Properties of colloids. First property, Brownian movement. It's a very important 3-mark question. Brownian movement, very important 3-mark question. What is the Brownian movement? Just assume that we are sitting in cinema theater. This is the screen. Okay. From back side, from the operator room, one light will enter, one light will come and reach the screen. Okay. From in the place itself, we can see that ray. In that place, the dust particles are moved here and there randomly. That random motion, nothing but what? Brownian movement. Okay. The dust particles will move here and there randomly, spontaneously. Okay. That only what? Brownian movement. See here, what is Brownian movement? The continuous, rapid, zigzag, chaotic, random and ceaseless movement exhibited by the colloidal particle in the dispersion medium is called a Brownian movement. The reason also we need. So due to unbalanced bombardment of particles by molecules of dispersion medium. Dispersion medium particle continuous attack here and there it is randomly it is moved. That's nothing but what? Brownian movement. Okay. Brownian movement. Next one is what? Tyndall effect. Optical property nothing but Tyndall effect. Tyndall. You know what is the true solution? What is the colloid? What is the true solution? Yeah, solid particle dissolved in solvent to form a solution. That's nothing but true solution. We can't see the particle size with our naked eye because the particle size is very, very small. That's a true solution. You know what is suspension? Sand in water. Okay. In a glass tumbler takes some amount of solvent, add lot of soil in it, dissolve well. If you dissolve half an hour also, it will soluble or not? It's insoluble. All the soil will turbidity appear, precipitate. So nothing but what? Suspension. Because particle size is very, very large, so that you can see with your naked eye itself. It's nothing but what? Suspension. What is colloid? In between these two, oil, milk, ice cream, these are colloid. This is my very same thing here. What is the Tyndall effect mean? Just we are going to take this one vessel, glass vessel. Here we are going to take true solution. What we are going to take? True solution. True solution. You know particle size of true solution very, very large or small? Very small in size. Okay. Now here from this side I am going to pass one film of light. What I am going to pass? Film of light. I am going to pass the light through the true solution. I am going to see from here. I can't see the path of light in true solution because particle size is very, very small. So I can see from here mean I can't see the path of light where in true solution. But very same thing, very same light I am going to pass through sol, nothing but colloidal solution. I can see the path of light. I can see the path of light. When I observe from here now, I can see the path of light. Why mean? Because particle size somewhat greater than true solution. So somewhat greater mean that particle scatter the light in all direction. That particle scatter the light in all direction. That's why we can see the path of light when you are passing the light through sol. That's nothing but what? Tyndall effect. Clear? Very same light we are passing through solution. We can't see the path of light when you are seeing with the naked eye because particle size is very, very small. So there is no scattering and all. But very same light we are passing in sol, colloid, we can see the path of light. Why? Because scattering the light, scattering of light. Okay. Read this 2 points, 3 mark question. Brownian movement and effect. Then Helmholtz double layer. That means, listen ma, this is a colloidal particle. It's nothing but what? Sol. Nothing but sol. Each and every sol, listen, surround that each and every one layer. Which layer? Positive layer is available. Okay. Then one positive means negative. Positive means negative. Likewise, one more layer also present. There is nothing but what? Negative layer. So around the sol particle, around the colloid, one is a positive layer, another one is what? Negative layer. So double layer. This is nothing but what? Helmholtz double layer. Each and every sol particle surrounded by two layers. That's nothing but what? Helmholtz double layer. One is positive layer, another one is negative layer. That's also 3-mark question. Okay. Next very important 5-mark question, electroborosis. Electroborosis, listen ma. Initially, we are going to take one U-tube. Okay. Here, we are going to take one sol, that means colloid. We are going to immerse two platinum electrodes. Which electrode? Platinum electrode. One is cathode, another one is anode. Here I am going to use one positive, one is negative. Which one is anode? Positive is anode, negative one is cathode. Okay. Here fully deionized water. Deionized. Listen ma. Now the concept is initially I do this side. Initial level. Your colloid will be negative mean it will migrate towards positive side. Where colloid charges positive mean to migrate towards negative electrode side. That's the concept. Okay. See here. So initially this much mean when you are applying electric field, that time initial stage till this much. When you are applying electric field, that time from this place to negative side decreased, the increased positive electrode side. This indicate your colloid must be negative. Colloid must be negative. Negative, because here we took arsenious sulfide. Arsenious sulfide is a negative one. It's a negative sol. Okay. Arsenious sulfide is the one negative sol. Yeah. So initially we took one U-tube. In U-tube we are going to take colloid, maybe positive or negative. Deionized water. Deionized water. You are going to introduce two electrode. One is a positive electrode, another one is negative electrode. That's a platinum electrode. Now we are going to apply electric field. That time our substance, our colloid is a positive mean, it migrates towards negative side. Suppose that is negative mean, it migrates towards positive side. Now our colloids, our sol is where's migrated? Towards positive electrode side. Isn't it? So this indicate our sol is negative because we took S3, that is a negative colloid. Clear? Sometimes they'll ask 3-mark question. What does electroborosis mean? See? Yeah. The movement of sol particles under an applied electric potential is called electroborosis. The movement of sol particles, that's a very important word. The movement of sol particles. The movement of sol particles under an applied electric potential is called electroborosis. Okay, electroborosis or other is called catoborosis. Very same concept we are going to use another one also. There is something electroosmosis. Electroosmosis. In electroosmosis, very same U-tube, very same U-shaped tube. Here you are going to take colloid. You are going to take clay. It is negative. Clay is with charge, negative charge. The medium is charge. The DNA is water. That is which charge? Positive. Our substance clay is negative charge. The medium is positive charge. Medium is positive charge. Here in electroborosis or catoborosis, which one is moved? The salt particles will move. Which one will move? Salt particle will move. Where salt is negative mean it will move positive side. Where salt is positive mean it will move negative side. Which one moved? Salt particles. But here salt particle will not move. The medium will move. Which one will move? Medium. Okay. Listen ma. Here that is very same positive electrode and negative electrode. Negative electrode. Your substance, that is a clay. That is negative only. Okay. So if you take this much level, positive molecule which side? Negative side. Negative side. So here it will increase. Here it will decrease. Can you able to understand? In electroborosis or catoborosis, the salt particle will move. When you are applying electric field, salt particle will move respective opposite electrode side. But in electroosmosis, the medium will move respective electrode side. Okay, your salt is negative, but the medium is positive, so that it migrates towards which side? Negative side, because the medium is positive. Clear? 3 mark they asked what is electroosmosis mean? Electroosmosis mean the movement of dispersal medium under the influence of applied electric potential, nothing but electroosmosis. The movement of dispersal medium, but in the case of electroborosis, movement of salt particle. The movement of salt particle is moved when applying electric field. But here the movement of dispersal medium, when applying electric field, dispersal medium is moved, means nothing but electroosmosis. Read the 2 questions, both are very important 5 mark questions. Electroosmosis and electroborosis. So over. Clear? You have any doubt? You have any doubt in electroporosis osmosis? No doubt. Okay. The next question. Why sky appear blue in color? I think very same question you learned in physics also. Why sky appear blue in color? Why? Because dust particle scatter blue light. See? Yeah. Because it contains very low wavelength is blue in color. See? Scatter blue light, dust particles along with water suspended in air scatter blue light, so that the sky look like blue. Okay, because very low wavelength. The next 3 mark question. Medicines. In that 1 mark question also will come. Most of the medicines are colloidal state. Why? The one mark question will come here. Colloidal medicines are more effective because they are easily assimilated. Colloidal medicines are easily more effective because what? Easily assimilated. That will come in body 1 mark also. First one is arginol. That is silver salt used for eye lotion. Second one, colloidal antimony used for collagen. Then colloidal gold intramuscular injection. Then fourth one is milk of magnesia for stomach disorder. But you can understand very easily. I learned from my school students. That means colloidal antimony, because you can, very important question. Okay, colloidal medicine. Colloidal medicines are easily assimilated. Okay. Only 4 medicines given. First one is you have to memorize no other way. Arginol, that is a silver salt used for eye lotion. One more is colloidal antimony. One anti, that anti name is Kala. Then we will not forget. Okay, the easy way. The antonym is what? Kala. So colloidal antimony is what? Used for Kala, sir. Okay. Then next one is milk. Milk is going where? In stomach only. So milk of magnesia is stomach disorder. Milk of magnesia is stomach disorder. Then the intramuscular injection, colloidal gold. Clear? The first one is arginal. That's a silver salt used for eye lotion. Then colloidal antimony, sir. Then milk of magnesia, stomach disorder. Colloidal gold, intramuscular injection. You'll forget or not? These points. Okay. This will come in 1 mark part. For example, colloidal antimony is used where? For color, sir. Colloidal, that means milk of magnesia, stomach disorder. Arginal, eye lotion. Then this one, intramuscular injection. Which one? Colloidal gold. That's a 3 mark question. Okay. Then tanning. That also 3 mark question. Tanning. Animal hides are colloidal in nature. They are passing positively charged particles soaked in tannin with contains negatively charged particles. The mutual coagulation takes place. Finally, hardening of leather. This process named as what? Tanning. You know what is all the animal hides? No, that's actually colloid in nature. When you add some of tannin, no, become positive, negative, mutual coagulation takes place. The colloid become a very hardening nature. That's called what? The process named as tanning. So, that 3 mark question. Then last question in this lesson, emulsion. What is emulsion? Already we discussed dispersion medium and dispersion phase, both are liquid-liquid combination. That is called what? Emulsion. Dispersion phase and dispersion medium, both are liquid-liquid combination. I mean, that's what? Emulsion. Can you give an example of emulsion? Milk and cream. These are examples of emulsion. Here 2 types of emulsion is there. One is W by O emulsion. Another one is O by W emulsion. What does W by O mean? Water in oil. I told already. What is the basic one? That is dispersion medium. What is going to have secondary material? That's called dispersive phase. Here first category, water in oil. Water in oil. So what is dispersive medium here? You are going to add water in oil. So what is dispersive medium? Dispersive phase. The second category, water. What is dispersive medium? Dispersive phase, oil. The examples given, that's very important. Some examples for O by W emulsion: protein, gum, natural and synthetic soaps. Very important 1 mark question. The example for O by W emulsions are proteins, gums and synthetic, natural and synthetic soaps. The examples for W by O emulsions are heavy metal salt of fatty acids, long chain alcohols and lamp black, etc. These are examples of which one? W by O emulsion. Okay. So emulsion mean dispersion medium, dispersion phase, both are liquid-liquid combination, mean you will get emulsion. Example, milk, cream, etc. These are 2 types. One is W by O emulsion, another one is O by W emulsion. W by O emulsion mean water in oil. Here oil acts as the dispersion medium, water is dispersion phase. O by W mean oil in water. Medium is water, dispersive phase is oil. Okay. Examples of O by W: protein, gum and natural synthetic soaps. What about example of W by O emulsion? Salt of fatty acid, long chain alcohols and lamp black. These are examples of first one, what? W by O emulsion. Okay. That's all lesson over, students. Yes. Then we'll discuss later. Then any doubt in this lesson? Colloidal solution? Any doubt? Book back 1 mark questions. Book back 1 mark questions. First one, the migration of colloidal particles under the influence of electric field is known as migration of colloidal particles. So, electrophoresis. Which one is the correct factor that explains the increase of rate of reaction by catalyst? Lowering the activation energy. Lowering the activation energy. Fog is the colloidal solution of liquid in gas. Liquid in gas. The phenomenon of Tyndall effect is not observed in because we can observe only in salt particles. The Tyndall effect associated with colloidal particles due to scattering of light. In case of physical adsorption, there is no desorption when temperature increases. Colloidal medicines are more effective because they are easily assimilated. Oil soluble dye is mixed with emulsion and emulsion remains colorless. Then the emulsion is O by W because oil in water. For selective hydrogenation of alkynes into alkenes, the catalyst used is PD mean what? Palladium partially inactivated by quinoline. For chemisorption, which is wrong. For chemisorption, which is wrong. It forms multi-molecular layer on adsorbate. An emulsion is a colloidal solution of two liquids. Colloids are purified by dialysis. Colloids are purified by dialysis. Then you know what are all the important 3 mark question, 5 marks in this lesson. So for 5 mark question mean first 5 mark question. Physical difference between physical adsorption and chemical adsorption. Second most, no important wise. Second most is that adsorption theory. Adsorption theory. Then condensation methods. Condensation methods. Then only dispersion methods. Dispersion methods. Then purifying salts. Purifying salts. 3 mark question mean Brownian movement, Tyndall effect, Helmholtz double layer, tanning, why that sky appear blue in color. Then 3 mark questions. Colloidal medicines are very useful one. Why? Then what is peptidization? Leophilic, leobobic. Why colloidal solution of gas in gas not exist? Because completely soluble to form a true solution. Then intermediate compound formation theory, promoters, catalytic poison, active sender, negative catalyst, positive catalyst. Very important one is octo catalyst. Then homogeneous catalyst, heterogeneous. What is catalyst? What is adsorption? These are 3 mark questions. Okay. What? Peptidization very important, 3 mark question.